Calculus in physics. As the name suggests, there is some aspect of math in physics. The students who are introduced to this topic that is there, called as calculus, find it a little weird and a little strange. At the same time, once they learn the concept, they find it consoling. The reason for this is they wouldn't have seen anything like this till date in the science that they would have studied, be it physics, chemistry, math, that they would have or even biology that they would have studied in their lower grades. So for a student who comes into grade 11 or the first PUC that is there, they would find this concept slightly strange. There is nothing strange about this. The first and the foremost fact that we have to acknowledge is nature around us has shown us a teen number of examples for symmetry. The patterns that are there are very much symmetrical in nature. For instance, if we take the leaf on a plant, the serrations that are there or the edges that are designed are perfectly symmetric about the leaf vein. If you look at the branches that sprout from a tree, they are in perfect symmetry. The human being anatomically is symmetric. The flower is symmetric. And all of this symmetry can be explained with the help of math. Especially calculus is the one that helps us in making sure that we can express whatever we see in the physical world in the form of mathematics, because nature always talks in the language of math. Calculus as such is not a very difficult subject if we can visualize what it is trying to tell us. So these equations here on the screen might look scary, but they are not, provided you have an understanding of what calculus is all about. So today, let us get into the journey to explore calculus in a way that you wouldn't have done it previously. Let's say I give you a graph which looks like this. So this can be, let's say, our velocity time graph. Now here, let's say I have a curve which looks like this. And if I ask you to derive the velocity time graph, or let's say the three equations of motion from this type of a velocity time graph, it's going to be a little difficult. You'll stop joking. But actually speaking, you can do it. Now, the method of calculus that is there, it involves breaking this curve into small strips. So that means what we will do is very, very thin strips we will cut. So we will get rectangular strips, but along with these rectangular strips, there is going to be a triangle that is attached with it. So we're going to strip it like this. Let's say coming here. Yes. So here you can see that there is a triangle. So a slope is there. But at the beginning of the curve, the slope is very, very small that is there. Now, the two methods called as differentiation and integration, what we are doing is, in case of differentiation, we are breaking it down. That means here what I'll do, if I have to calculate displacement, I will break down the area under this curve as very, very, very small rectangles. So I will have a rectangle and triangle that is there in this kind of a column. And then I will find the displacement individually for all of these geometric shapes and then put everything together. The other one, that is integration, I will actually do it in a different way. It is the reverse process of differentiation. So we can tell differentiation is the reverse of integration, or integration is the reverse of differentiation. It wouldn't make much difference because these are mathematical processes bound by mathematical laws that are there. So what do we do in integration? Differentiation, we broke it down. Integration, we will take the entire thing. So in order to understand this, we will go ahead and do a small mathematical problem. So before we get to that, let us look at how we can differentiate. Now the only two formulas that you would need to know here is this. So I will have d by dt of x power n is equal to n into the x power n minus 1. This is a differentiation. And integral, let's say if I have x power n here only, x to the power n dx, this is going to be x to the power n plus 1 by n plus 1. So we're just going to use these two formulas and do the integration and differentiation. Now this topic will be covered much more in detail in math, but we do require these expressions from time to time in some of the chapters that we are going to solve. So we will look at its understanding right now. Now I have written x. X is the function that is there. For instance, you would have written y is equal to mx plus c when you were in school. So when you had to draw a straight line graph, this is your expression. What is the understanding? The variation in the value of x gives you your value of y. So that means x is a function of y. Exactly the same thing here. X is a function of t. Now, in differentiation, we are breaking it down. Integration, we are putting it together. So what we will do is, let us take a brief equation. So I'll give you one expression and we will go ahead and differentiate it, and then we will see what happens. Now I will call displacement, that is y is equal to, let's say, instead of x, I will take time. So 4t square plus 3t plus, or we'll take a cubic equation that makes it a little more interesting. 4 3 cube plus 3t square, 12t plus 6. Now a couple of things that you have to understand. Whenever we are differentiating, the numbers that are there or the constants that are there, we are not going to touch. So here if you see, I can do a small addition. This is t power 1 and this is t power 0. It is a well-known fact that anything to the power 0 is equal to 1. So that means I'm not altering the equation. I've just made some subtle changes. Now, velocity is given as rate of change of displacement, that is dy by dt. Now, how did we arrive at this d by dt? It is known in, let's say, it's a general tendency for human beings to have work done in the shortest possible time. So if we look at the other version of this, which we are familiar, it is nothing but delta y by delta t, that is change in displacement with time. Now the idea here is, if the change in displacement is much higher for a small value of time, we will get a greater velocity. That means effectively we are taking a steeper slope that is there. So in the VT graph, we are taking a graph which looks like this. So it has a steep slope. Now here we understand mathematically that if we apply a limiting condition, delta t tending to 0, that means it's becoming a smaller value but not exactly 0. This would convert this delta and all these operations into dy by dt. Now this is the understanding that is there. So let us take this equation forward and do the differentiation that is needed. Velocity is dy by dt. Now I will write it as 4 dt cube by dt plus 3 dt square by dt plus 12 dt to the power 1 by dt plus 6. Now t power 0 is, okay, we'll just write it, d by dt of t to the power 0. Now from the formula when we apply, we can simply write it like this. If it is, let's say, d by dt of t cubed. Now what is our formula? D by dt of t power n is nothing but n times t power n minus 1. So applying the same formula here, dt cubed, that means n is 3, you write it first, t to the power 3 minus 1, which is 3t square. Similarly, d by dt of t square, it becomes 2 t to the power 2 minus 1, which is nothing but 2t power 1. d by dt of t power 1, it is 1 t to the power 1 minus 1, which is 2t power 0, which is equal to t. So this is 1 into t to the power 0, which is equal to 1. And now we have d by dt, the last one, as t power 0. So it becomes 0 into the power 0 minus 1. So 0 into anything is 0. So therefore, we can write our expression velocity as dy by dt as 4 d by dt t cubed plus 3 d by dt t square plus 12 d by dt t power 1 plus 0. Now substitution, I will get 4 into 3t square plus 3 into 2t plus 12 into 1 plus 0. So our expression now will be 12t square plus 6t plus 12. So what have I done? I have reduced the cubic equation down to a second order or a quadratic equation that is there. This was the third order equation, that is in terms of displacement y. I have reduced it to a second order or a quadratic equation. Now this is velocity. We can go ahead and do acceleration. Now what is acceleration? So I'll just simply write velocity here, which we got it as 12t square plus 6t plus 12. Again, for our benefit, this is t power 0, this is t power 1. Acceleration is rate of change of velocity. So I can simply write it as dv by dt, but v is equal to dy by dt. So that would imply acceleration is d by dt of dy by dt, which is nothing but d square y by dt square. That means we are differentiating the displacement 2 times in order to arrive at acceleration. So mathematically, this is what it means. So here we are not using any graph. We are just using a formula and we are doing it. So let us go ahead and find acceleration. So acceleration is dv by dt, which is nothing but d by dt. We need not write this as d square by dt square of y because already we have differentiated it once. So this is going to be 12 times d by dt of t square plus 6 times d by dt of t power 1 plus 12 times d by dt of t to the power 0. So let us go ahead and solve the d by dt's and then we will see. So d by dt of t square will be nothing but n is 2 t to the power 2 minus 1 of t power n is given as n times t to the power n minus 1. So this will give you 2t d by dt of t power 1 is 1 into t to the power 1 minus 1, which is 2t power 0, it's not 2, it is 1t power 0, which is equal to 1, and d by dt of t to the power 0 is 0, t power 0 minus 1, which is equal to 0. Now, we will go ahead and substitute these values in our expression. So in this expression, when we write, we will get 12 into 2t plus 6 into t plus 12 into 0. So the equation that we will finally get here is acceleration is equal to 24t plus 6. This is t power 0. So plus 6 is what I'll get. So I can actually write the final expression like this. Acceleration is equal to 24t plus 6. So you can see when we are differentiating what we have done, we have reduced the power from 3 to 2 to 1. So we've made this a simple straight line equation from a quadratic equation. So if I call this process as differentiation, the reverse of it is called as integration. So we can always understand that integration and differentiation as two up and down processes. Now, what is the use of doing this? So we'll go ahead and plot a graph. So for that, what we will do is we need to prepare a table where we have got the time that is varying. So 0, 1, 2, 3 up to a given number. We will have the values of y, velocity and acceleration. So we can plot a graph of v versus t, that is, let's say distance versus time, velocity versus time, acceleration versus time, and see how this graph looks. So here I have a table which has the x-axis in terms of time, y-axis in terms of the displacement. This is the equation that we have. Again, another y-axis for velocity, and these are the values, and the final one, acceleration, and the values. So you can see that when time t is equal to 0, for y it is 6, for velocity it is 12, and for acceleration it is 6. So accordingly, I have used the formula and I have calculated these values. So first let us plot, let's say, displacement and time and see how the graph looks. So this is how our displacement time graph looks. So it's a smooth curve which is moving upwards. Now we will plot, let's say, velocity time and see how the graph looks. Okay, so you have another curve that is there compared to the first one. We'll not be able to make out much difference here, but still, again, this is a curve. And let us plot acceleration and time and see how the graph looks. Okay, looks like a straight line. Now, in order to understand what I'm trying to tell with these graphs, I will plot all of them in the same graph with respect to the x-axis, that is with respect to time. So when I plot all of them together, you can see that my value that is there, in this case, if I see the black dot is giving me the displacement curve that is there. The red one is giving me the velocity, and the triangle, the blue one, is giving me the acceleration. So you can see what happens when I'm differentiating. The slope that is there, the tan of the angle, tan theta, is decreasing. So here in terms of y, you would have a very good slope. You can calculate velocity. When you are, let's say, plotting a velocity time graph and you try to find its slope, you will find acceleration. Acceleration time graph, there is no slope that is there. So using this one plot, we can see that when I'm differentiating, what is happening is from a third order or from a cubic equation reduces to a quadratic and then finally reduces to a simple equation of the first order. Integration would be reverse. You can start from the first order and reach up to the third order that is there.